In set 1, question 1, we're looking at Pythagoras' theorem. Now, Pythagoras' theorem says the square of the hypotenuse is equal to the addition of the square of the other two sides of a right-angled triangle. Now, it doesn't matter which side you call A and which side you call B, as long as you identify the hypotenuse correctly. In 1A, clearly we've got the hypotenuse at x. So in this instance, 8 squared is equal to 12 squared plus 16 squared. Now on the calculator, 12 squared plus 16 squared gives me 400. Now clearly, that's not going to be the length of the hypotenuse. So h is equal to the square root of 400, which is 20. Now we haven't been given units here, so we'll just leave it at 20. When we look at question C, even though the triangle appears to be on its side, we are dealing with the hypotenuse. The hypotenuse is the length opposite the right angle. So in this instance, p squared is equal to the addition of the square of the other two sides. So 84.5. Now, that clearly is too big for the side length, so we take the square root. I simply raise that to 0.5, and that's 9.19. Looking on to G, you'll see we've got a much skinnier looking triangle, but clearly the hypotenuse is the 9.6. We're identifying side length A. So I've just redrawn that for you. I'm going to find the square of those two sides. Now I've got to do some transposing here. So a squared is equal to 29.92, and taking the square root of that, gives me 5.47. Key thing with these problems, identify what the hypotenuse is, write out Pythagoras' theorem, and work it through. When you have a non-hypotenuse side, such as we had in G involved, you must make sure that you are transposing as you go. You'll get a very silly answer if you were to call that the hypotenuse.